This is the sixth note of the fourth unit on statistics. This is the last note where we will be talking about common distribution properties. So this note, like one that I've done before, is already fully filled in. So if anything, I'll just kind of be adding notes on the side, but it might be smart for you to just print off the completed note for this one because there is a lot of info and it is one of those longer notes again. So histograms can take on any of several common shapes. So among these distributions are, so it could be symmetrical, right? Which means that both sides are going to look somewhat the same. So there's three types of symmetrical distributions. There's normal distributions, bimodal distribution, and uniform distribution. So we are going to kind of dissect that as we go. There's also skewed. So your data could also be either right skewed or left skewed, and we will expand on that a little bit throughout this note. So using the information, which we know match your example and graph to the appropriate definitions. Okay, don't worry about that. That's just a little bit of a activity that we're not going to do for now. Maybe we'll do it in one of our meetings. Okay, so normal distributions. What is a normal distribution? So these are commonly referred to as that bell curve or mound-shaped distribution. So I showed you an example of that on the last note. So the middle intervals will have the greatest frequency. So your tallest bars will be in the middle, and the other intervals will have decreasing frequencies as you move away from the center of the graph. So that just means that the bars are going to get smaller as you move out towards the edges. So for example, if we have a pair of dice and they are rolled 75 times, after each roll, their sum was recorded and graphed. So we can see we have options for the sum on the dice, right? 2 to 12, and the frequency is how many times those were rolled. So if we look at this graph here, we can see that in the middle, that middle number was rolled the most, right? And as we go either to the left or to the right, we can see that those bars are getting smaller. So this is that bell curve, right? Where it's supposed to kind of look like a bell, right? A bell kind of has that shape like this, where the little bell thing is in the middle. Okay, so that's where that name comes from. Okay, so even though this isn't perfectly symmetrical, it still fits in that definition of normal distribution, because we can see like it's not perfect, right? 9 here technically could be like a bit higher to make it look a little bit better. Same with 11, but it generally fits that curve. So that is what we would refer to as a normal distribution. Okay, just pulling up the second page. So the second type of distribution that we could have is bimodal distribution. So these look like inverted normal distribution. So remember, inverted is just a word that basically means opposite. So the intervals with the highest frequencies, which is the tallest bars, are at both ends of the graph. And the interval with the lowest frequency is in the center. So frequencies increased as you move away from the center of the graph. So for this one, we looked at the middle, and we're going to get higher as we go out, whereas that last graph, the highest peak was in the middle. So for example, a class of grade 6 and grade 1 students each measured their heights. They recorded and graphed them. So we can see in our little T-chart here, we have heights. Okay, so the kind of ranges for heights and the frequency that they occurred in both grade 6 and grade 1 students. So we can see that on the kind of left-hand side of this graph, that most students were at the very start, right? So most students were 110.5 to 115.5 centimeters, okay? But if we go and look on the right-hand side of the graph, we can see that a lot of the students were also 155.5 to 160.5 0.5 centimeters. And again, this makes sense, right? Right, guys? Think about it. Obviously, the grade 1s are going to be shorter, and the grade 6s are going to be taller. That middle, where you'd be kind of in the middle height, it's less likely because you're starting with grade 1 and grade 6. Maybe if you also put grade 3 in there, then those middle heights would become higher. Okay, so we can see that this is kind of the opposite shape as before, where we have the highest point on the end. So it's kind of that upside down bell curve, or that upside down bell. So again, if I draw that bell, the little thingamajig is here, we can see that that's a similar shape, right? So it's just an upside down bell. Okay, uniform distribution on the other hand is the frequencies of each interval are approximately equal. So if we were to roll a die 50 times and record what face comes up. So obviously there's only like 6 options, right? 1 to 6. And we recorded how often each of them came up. As you can see here, I can basically draw a straight line across my data, okay? When I can draw that straight line, that means it's a uniform distribution. And this did come up in a note earlier on as well. So you should be kind of aware of that one as well as that bell curve. The bimodal one is the only one that you haven't seen yet. Okay, so we're rolling through this pretty quick. There's one more page where we are going to look at those skewed distributions. So from that first page, I told you it can be right skewed or left skewed. So let's look at these here. So skewed distributions, like I said, 2 types. So in right skewed graphs, the bars with the highest frequency are on the left, and the frequencies decrease as you move right. Okay, so as you can see, our highest are on the left, and as we move that way, we are decreasing. In a left skewed graph, the bars are the highest on the right side. So it's kind of the opposite of what you would think. If you hear right skewed, you might think highest on the right, but it's the opposite. Okay, right skewed means the highest is on the left, left skewed means the highest is on the right. And again, we're getting smaller as we move in that direction. Okay, so an example of this, Sally picked up a handful of quarters. She recorded the year of each and made a graph. Okay, so you can see that we have different categories here, starting with 1955.5. I don't know why there's the 0.5, but whatever. 1955 and going all the way to 2010. So as we can see, there's obviously a lot more quarters that have dates from 1985 to 2005. So if we look at this data here, we can see that as we move to the right, we are getting larger. Okay, so even though there's a low frequency bar on the right side, which is referring to this guy here, right? See how that technically, if it was going with our pattern, it really should be kind of up here. Even though it's like that, the general trend is still moving up to the right. So we would still consider this trend left. Okay, if it were right skewed, that would mean that she would have most of her coins from 1955, 1960, all the way to like 1975, right? And she would have none from kind of the 2000s. Okay, so this was the last note of this unit. So you are done Unit 4 on statistics.